This is Sean O'Neill, DatastructuresCA2 screencast. I've got my program running here in the background. It welcomes you to the database menu and then asks you to enter a password. It's not any predetermined password, this is where it's asking you to enter it in. Whatever you enter in here will be your password for the remainder of the program running though. So just try and remember. I'm going to enter in Sean with a capital S, and case does actually affect it, so it's case sensitive. And then it displays the menu, asks you what you'd like to do, displays all your options. I'm going to press 1 to insert, and then I'm going to insert someone at index 0. Name is going to be Sean, second name is going to be O'Neill, and then it asks you it says to access the level and exp functions you have to enter your password. So I'll enter in Sean, and then I get administrator privileges, so I can enter the player level 10 and exp 100. And then I'll enter in someone else, so we'll put a John Doe, and then I'll just mess up on the password, and it says password incorrect, setting the level in the exp to the default values, which is 0 and 0, which would be starting level and starting experience, which is why I decided that if you want to actually set the level and experience, you need administrator privileges. 2 deletes a record from the specific position. 3 searches a database and prints the results. 3 has nested menus in it though, so I'll just show you 3. The first option is search for a record based on the first name, second is based on a surname, and third is based on level. Third has submenus, so I'll go into the 3, and then you open the level search submenu, and then it asks what way you want to search. You can search based on a single level or within a range. Single level takes in 1 parameter, range takes in 2, and searches in between those 2 levels. 4 finds the average experience points for all players of a particular level, takes in 1 parameter, which is the level that you want to search for. And 5 searches through the entire list and removes all duplicate entries. It keeps the first entry of each. And then when you want to quit, it asks, are you sure you want to exit, yes or no? Yes. And it exits. So this is my main app. I know I haven't included the timer code in this either, which I was also faulted for in CA1. But to be honest, I kind of ran out of time with the CA. I was just very confused with all of the iterators in this, and it got a bit ahead of me, so I just lost track of time. I started, I think, a week and a half or 2 weeks before it was due, but it got ahead of me. It got away from me, sorry, in time. Before I knew it was just on top of me. So that's why I didn't get time to test my functions with the timer. I have the memory leak code in it though, that's here. This is my includes, they're my usings. This is where I set up all my variables, because I didn't want to have them set up at the start of each loop, because then you're just wasting performance if you have to set up your variables, redeclare them each time. So I just declare them at the start before we enter the loop. Yeah, put the welcome menu once, then you start your loop, because you don't want to keep outputting the welcome menu and asking for the password every time. There's the menu, then it just goes into switch statements, and there's enums for the for each switch statement, and it has all the inserts and everything. And the doubly linked list is where the majority of the stuff happens for this CA. The double linked list class is very similar to the single linked list class that we did in class. We have our forward class declarations here, which is just saying that you're going to use some types that probably aren't defined already, but just tell the compiler to keep going anyway, and that they will be declared eventually. We have the dlist node class, which is your node. It contains a pointer to for the doubly linked list, it contains a pointer to the previous node, the next node, and it contains the data. it has an insert after function that just is in how you insert a new node. It just it rearranges the pointers and then it creates a new node and makes the new node have pdata, which is the new data. It should be generic because it's got data types inserted in, so it should be able to take any data type. And then we have the delinked list class, and that is a collection of nodes, and it just it dictates how everything behaves, how all the nodes behave with each other. I have overloading, iterator overloading here. So I have a begin and an end function for my iterators, and I've type defed my dlist iterator of type data type to iterator. So just in case you were wondering where iterator came from. So I have a begin and an end function, so I can call dot begin, and it starts me at the start of, or my head here, starts me at the head node of the list, and then I can iterate through. And if I want to call end, it puts me at the tail. The default constructor here has an initializer list. There's the destructor. The append function and the prepend function are both very similar to what we did in class, as is the insert function and the remove. The remove head and the remove tail are the same as well. Because I didn't need them in my project, really, I didn't change them. And the get iterator save to disk is there, and so is read from disk, but I didn't implement them, so they're commented out at the moment. They are the same as what we did in class though. I have then my dlist iterator class, and that determines how the pointer behaves when iterating through the list. And then I have my operator overloading done here, which just allows you to it provides kind of pet comforts that we have with other data structures that are already implemented, such as the plus plus function, the minus minus function, the not equals to and the equals to functions. And then I have my constructor for my dlist iterator. I have start and fourth. Start puts you at the start, and fourth iterates through one node at a time. Back moves the iterator backwards. The conversion, I needed at an earlier date, and I needed at an earlier date more than I do now, but in the fitness project it's used for taking in the position that you want to insert a player into, because it takes in an int, and that was throwing an error at first because you need an iterator. So this takes in an int and changes it to an iterator. Valid checks to see if the iterator is still valid, and item is the item that the iterator currently points to, so kind of dereferencing it if you need to know the actual value of what the iterator is pointing at, not just where the iterator is pointing. The player.h just is a player object class, and it's the implementation class for it, and the CPP is the actual class. It just has a a constructor, a print me method, so it knows how to print itself out. It's very similar to a toString for most objects. Just like renamed it print me as a bit of a jolly thing, I guess. It then has its getters and setters, and apart from that it's not much extra. I just built it so I would have player objects to insert into my list. The player record holds most of the functions, so it has search functions. It has all my search functions, and they are search surname, search first name, search level, and search range. The search first name, surname, and level are pretty much what they say on the tin, but the search range is the level search. It's the range level search that takes in one level and the other level, and then it finds anyone with a level in between those two. And then the way the search functions work are they return a vector of player objects, and then when you go into the loop, when you first start it, you create a vector of player objects. I called mine hits. So then you create your for loop, you create an iterator, and you start at the beginning. So you call the plist, you call .begin function, so it starts you at the beginning. And then you have iterator until iterator is not equal to plist.end. Sorry, for as long as iterator is not equal to plist.end. So it keeps going until the end of the list, and then iterator plus plus. So there's 3 examples of my operator overloading right there in that line. And then the if is for the surname function anyway. Iterator.item, so you're dereferencing it in essence, and then you're saying .get surname. So you get the surname of the item, which would be a player object, and the player object would get its surname, and then it compares it with the equals equals function to the p surname that you pass in. And if they're equal, you push it into hits, which is the vector of player objects. You push that player into the, if they're not equal, you just carry back around and try again, and we'll go on to the next one. And then I just have my checks here. If hits.size, so if at the end of it the vector of player objects is empty, just return no one with that surname was found. And then you return hits there at the end, so you can then do stuff with the array afterwards. The first name function is pretty much the exact same, except it's just checking first name as opposed to surname. The levels function is very similar as well, except it just checks the level of the player. And the range level function is also very similar, except for in the if statement it checks to see if it's between level 1 and level 2. Then do it. My print function just pretty much calls the individual player object's print function, so it makes it print itself, and then it can loop back around, so we can do it for an entire list. So it just goes for the list saying player print yourself, player print yourself, player print yourself. The remove duplicates function takes in the first name and a surname and the list that it's going to be searching through. It has a vector of player objects called hits again, and then it just sets up the same as the other search functions, because it is actually in essence a repurposed search function. And then, but the way it looks for it is, it says if the dereference, if the item's item.get first name is equal to the first name that you passed in and the surname are the same, then you push it back. However, it says if the hits vector gets bigger than 1, then you remove the current object. So the object that the iterator currently points to, which is here, so it'll come around, and if it finds, say, a Sean O'Neill, it'll go, that's okay, I don't have one of those. But if you're searching for Sean O'Neill, it'll say, I'm looking for Sean O'Neill, there's a Sean O'Neill, it'll push it into the vector, it'll have 1. If it goes back around and finds another one, it'll say there's another Sean O'Neill, push it into the vector. But then it'll say, okay, the vector is now bigger than 1, so I'll remove the current Sean O'Neill. And then it'll carry back around and do the same. If it finds another Sean O'Neill, it'll delete that one, so it keeps the first instance of the Sean O'Neill and deletes the rest. And the average function just averages the contents of an array, so you'll search through and then take the average. You take in the list you want to search through, or sorry, you'll take in the vector of player objects that you want to search through. So the way I do it is I call it in main, I call the search function first, that checks all of the exp for that level, and then it just calls an average function on the vector that gets passed back. So I set up my total variable, that's a double. I search through it and I add you search through the list and you add all of the players .get exp. So you get their exp, then you add that to the current total,